In the next few videos, we'll be talking about equations for lines, planes, and spheres, and we'll use our knowledge of vectors to specify and give various ways of expressing these geometric objects in an algebraic way using equations. I will start with equations for lines, and by saying that a line either in space or in plane can be specified in various ways. One such way would be to, and I'll draw a figure to illustrate this. So here is our line. Let's call this L. So a line L in the plane or in space can be specified in various ways depending on what data we have. So let's say we have this line. Here is the origin. We fix the origin to be there, and we want to give the points on this line a characterization by an equation. So what I mean by that is, let's say we know one point on this line, P. So for example, that would be one way of characterizing a line, by a single point on it, and a direction, a vector that points along the line. Okay, so if we have, let's call this V, vector V. If we have these two things, a point on the line and direction, a vector that points along the line, in the direction of the line, we can specify the all points on the line by an equation. So fix a point P on the line and a vector V along the line, then if we want to express an arbitrary point on the line, let's call this one Q, with coordinates X, Y, and Z, what we would do to get to that point, what we have to do is, first we have to go from the origin to this point on the line which we know. So we go from O to P and then go from P to Q by basically taking a scalar multiple of V. Okay, so let me draw a vector like that as well. So this is some scalar multiple of V, which we need to get us from P to Q. So for an arbitrary point, Q on the line, we get that the vector going from O to Q, the vector OQ, this one, can be expressed as the sum of the vector from O to P plus some multiple of this vector V. So for some S in R. So this is the first, this is our first equation for a line. Okay. If we let the coordinates of P be P1, P2, and P3, and the coordinates of our vector V to be V1, V2, and V3, it will give us the following equation: x, y, z, this triple of coordinates for the point Q can be expressed as P1 plus S times V1 as the first coordinate, P2 plus S times V2 as the second coordinate, and P3 plus S times V3 as the third coordinate, where again S is some real number. And in fact, if S runs through all possible real numbers, this vector given with these coordinates will sweep through the whole line. So as S is changing in the set of real lines, the point Q is going to be moving along the line. Okay? Because S is giving us a multiple of our vector, so stretching and shrinking and flipping the vector will take us along the line for an arbitrary point. We can find such an S. Okay. Now next, I want us to have an example. So I want you to consider the following example. Let's say that the point that we have, that we know it's on the line that we are interested in, has coordinates 1, 2, and -3, -1, and the vector along the line of our interest has -2, 3, and 4 for its coordinates. I want you to give me its equation, and this equation is referred to as the parametric equation for a line. So I want you to pause the video and calculate the parametric equation for the line given by this point and this vector, and use the box to input the equation. Okay, I hope you did the calculation and have found that x, y, z, the points on the line, have coordinates which are 1 minus 2s, 2 plus 3s, and -1 plus 4s, as s, the number little s, runs through the set of real numbers. Okay, so but this is only one way of expressing a line by a fixed point on the line and the vector that points along the line. Now there is another, at least one equivalent way of doing it. What if we have 2 points on the line, fix P1 and P2 on the line? Well, if we have 2 points on the line, let me draw a separate line. So if you have 2 points, P1 and P2, and you know the coordinates of these points, well, it's quite similar to the previous example. Once you realize that all we have to do now is we go from the origin to one of these points, P1, let's say, and then P1 can take the role of this point P. The only thing we need then is this vector that points, a vector that points along L, and that vector could be the vector going from P1 to P2. So this is the vector P1 to P2, which is equal to the vector OP2 minus OP1. Okay? So this is how we can express now write the equation of a line using 2 points given on the line for an arbitrary point Q on the line, we have now OQ equal, in this case, OP1, the vector OP1, plus S times the vector P1 to P2, with S being a real number. Okay, so this is yet another equation which uses 2 points on the line. So if we are given 2 points on the line with their coordinates, we can also calculate an equation for our line. So what I would like us to have now is an example of the second possibility. So let's consider the equation, the line going through the points P1 and P2, with P1 having coordinates 5, 3, and 0, and P2 having coordinates -1, 0, and 2. Okay, so I want you to take these 2 points and give me the equation for the line going through them. Okay, I hope you pause the video and put your answer below. So for this problem, we will have to have x, y, z being equal to, well, OP1 is just simply 5, 3, and 0, and we have to add to these numbers s times the difference of these two. So let me first quickly calculate the difference of OP2 and OP1. It will be just simply taking the first coordinate of P2 and subtracting the first coordinate of P1, and so on for all coordinates. So I get -6, -3, and 2. So this will be 5 minus 6s, 3 minus 3s, and finally 0 minus 0 plus 2s. So this is the equation for our line passing through these points. Okay, I hope you got it right, and I'll see you in the next one.